Oh my God. So a robot is a machine capable of carrying out a series of tasks automatically. When we think of robotic surgery, we think of the scenes in the movies that we watched. Whether it's the robot tending to the wounds of a soldier in Starship Troopers, or Anakin Skywalker being transformed into Darth Vader, the alien Caesarean in Prometheus, or an uploaded intelligence curing blindness in Transcendence. But the truth is far from it. The most famous surgical robot, the Da Vinci system, consists of 4 arms which are then controlled by a surgeon inside a console. It helps us do minimally invasive surgery in cardiac, abdominal, or in pelvic surgery. Sadly, we don't even use it in neurosurgery. In neurosurgery, the robots that we use help us to stabilize the head, to calculate targets in 3D space inside the brain, and to plan safe trajectories to those targets deep inside the brain. And we use these robots to place deep brain stimulation electrodes or SEEG electrodes to find out the epileptic foci, or also to take biopsies of tumors or any other lesions in the brain. We also use them in spine surgery for accurately placing the pedicle screws and interbody cages. Robots like ROSA, NeuroMate, Stealth AutoGuide, ExcelsiusGPS, and Mazor X are all built on similar principles. They usually have an arm which places itself precisely in 3D space in reference to the patient, so that the surgeon can place tools through one arm of the robot to perform certain steps in the surgery. There are also endovascular robots like the Corindus CorePath, controlled by a surgeon in a console, and the surgeon can move wires into the blood vessels and can deploy devices using the robot. There's also an iArms which helps the surgeon rest their arm while doing surgery so that they don't get a tremor and they don't fatigue easily. Now, robots can increase accuracy, reduce radiation exposure to both the patient and the surgeon in endovascular and spine procedures, can increase the operating room efficiency if they are integrated into the workflow efficiently. But robots are expensive. They may take more time to set up than actually doing the steps in surgery, and hence they can increase the operating time and the anesthesia time for the patient. They can still have errors, and when a robot fails in placing a pedicle screw, the surgeon will have to step in and they have to know how to place a pedicle screw without a robot. Now, Elon Musk did tweet that robots will be as good surgeons in a few years, and that Neuralink had to use a robot to implant its electrodes. But that's the thing, the robot only placed micro electrodes. A neurosurgeon still had to be there to do the other steps of the surgery. Here, the robot is just a tool. When you need to tighten a screw, you don't use your finger, you use a screwdriver. And in his tweet, the Hugo robot that he was talking about has an RAS in it, which means robotic assisted surgery. And the Hugo RAS does work in a similar way to the Da Vinci system, where a surgeon controls the robot through a console. Now, I do admire the ambition in his statement, but I want to point out why it's a bit optimistic. Now, the brain is not a repetitive environment. Each person's anatomy, each brain, each tumor, AVM or aneurysm is different. Humans understand concepts and they are adaptable, while robots excel in doing repetitive tasks. Humans will never be on an assembly line where robots can operate on an assembly line. Every person's tissue, whether it's brain, bone or skin, reacts differently. There's no AI model which quite understands that yet. Every step in neurosurgery is calculated, is precise, and it's nuanced. Any mistake can lead to deficits for the patient, and the understanding of the effect of a deficit on a patient can only be understood by a human, and that's what makes surgeons more careful. Needless to say, empathy is not a function of a robot. No AI robot will ever understand the ethical weight of neurosurgery. Selecting patients, explaining complications and risks, handling the complications. No robot can take responsibility for its own actions. I personally think that the human brain is too precious to delegate. Not only do you not want an autonomous robot poking into your brain, but you want an empathetic, careful, responsible, skilled human as your neurosurgeon. The main problem as to why people think that robots can take over neurosurgery is that they don't understand the nuances of the art. They think it's just a bunch of repetitive tasks and manual labor. So personally, I don't think robots will take over neurosurgery, but they will be used as tools to make neurosurgery more precise, efficient, and safer. So that's all for this video. If you have any topics that you want me to talk about in regards with neuroscience or neurosurgery, please do comment below. I'll make a video on that. Till next time.